Assalamu alaikum everyone. Welcome back to my YouTube channel. Welcome back to the YouTube channel of Study with Hania. So in today's video, I'm back with you guys with another lecture regarding science, and let's begin with our today's lecture. Assalamu alaikum. The topic today we are going to do is structure of an atom. We are going to be studying all the things regarding an atom, what is present inside it, what's structure, what are the types of particles that are found in it. Okay, all the things regarding the atom. So, what is an atom? So, an atom is the smallest unit of matter that retains the properties of an element. So, it retains all the properties of an element inside it, and it's the smallest unit of matter. So matter is anything that consists of mass and has it has specific space occupied by it. Like it has volume. So this is atom is the smallest unit of matter. Got it? Now, everything around us, including plants, animals, objects, and even our own bodies, is made up of atoms. Nothing in the world is we can't say that anything in the world is not having atom. Everything in the world has atom. Everything, like even though our body particles, they're also consisting of atoms. Okay, an atom has a central nucleus that contains protons and which have positive charge, and neutrons which have no charge. No charge means that we just put a degree on it, like that means it carries no charge. So there is a nucleus of an atom which is present in the central area of an atom, and it carries two particles or two elements of it, which are protons and neutrons. Protons basically are the positive charges, and neutrons basically they have no charge. Okay, then electrons, which are negatively charged, move around the nucleus in shells or energy levels, or you can say they move around the okay so they move around the atom in the orbit. Now these electrons, they move, they gather, they basically keep moving around the atom, carrying negative charges with them. The number of protons in an atom determines the type of element. Like if I say, let's take helium. So helium, it has two protons. Okay, helium has two protons and its atomic number is also 2. So now 2 is gonna be its atomic 2 is gonna be its electron number as well. So electron number and proton number is always same, so they cancel out each other's effect. As a whole, an atom becomes neutral. Okay, and neutrons, like if you talk about the neutrons in helium atom, there are two neutrons. So what is going to be the atomic mass? Atomic mass is going to be 4, because proton number plus neutron number is equals to atomic mass. Okay, now these type of protons in atom determines the type of element. So like if I talk about hydrogen, so it has atomic number 1. Its number, like it's present the first element, its atomic number is also 1, its proton number is also 1, and its electron number is also going to be 1. Okay, so the identity of an atom is basically proton numbers, because in the order of increasing atomic number an element is placed. Okay, even though atoms, the number of protons in an atom determines the type of element, which electrons are responsible for chemical reactions. Now, all the chemical reactions, or all the ions or covalent bonds that we make, electron is responsible for that. Okay, that's electronic configuration. We do that, and then we do the distribution of electrons, whether it's gonna gain, lose, share, and all that, valency, valency, and all that. Okay, even though atoms are extremely tiny, they are building blocks of entire universe. Now, even though they are a tiny unit of matter, but they are, so even though they're the tiniest particles, they are the building blocks of entire universe. Okay, what an atom contains. Okay, what an atom contains, this is the main thing you should know about an atom. So an atom contains three main things. First of all, protons, neutrons, and electrons. So protons are positively charged particles found in the nucleus. I told you about this. They determine the identity of an element. Now I told you this, that identity of element is basically protons, because they are placed in the order of increasing atomic number. That is, atomic number is proton. So identity of an atom or element is basically protons, number of protons, because they are basically, according to them, the elements are placed in the order of the increasing atomic number. Neutrons, neutral particles, that means they have no charge. Also in the nucleus, they add mass to that. Now they add mass to my atom. That means that if I say mass number is equals to proton number plus neutron number, so basically in what the main usage of this neutrons is that they add the mass number. Okay. Electrons, negatively charged particles that move around the nucleus in shells or energy levels or orbits. They are responsible for chemical reactions that I told you, that all electronic configurations and all the things that happen in the orbits or in the shells. For that purpose, electron is responsible. Okay, so these are the elements. What are present? Where are these particles present? So now you need to know about where are these particles present. So the three main particles of an atom are present in different parts of the atom. Protons, they are found in the nucleus at the center of an atom. Neutrons also found in the nucleus alongside protons. Okay, they are also present alongside protons in the nucleus of an atom. Electrons found outside the nucleus, moving in shells or energy levels around the nucleus. Okay. What is mass number? So the mass number of an atom is the total number of protons and neutrons present in the nucleus. So mass number is equals to total number of protons plus total number of neutrons present in the nucleus of an atom. The formula that we use for it is mass number is equals to number of protons plus number of neutrons. Now, examples like oxygen has 8 protons and 8 neutrons. So what's going to be its mass number now? 8 protons plus 8 neutrons. 8 plus 8 is equals to 16. That means that mass number of oxygen is going to be 16. And what's going to be atomic number? Atomic number is number of protons present in the nucleus of an atom. So atomic number is going to be 8. So what is an atomic number? The atomic number of an atom is the number of protons present in the nucleus. And the number of protons present in the nucleus is called basically the atomic number. It defines the element. For example, hydrogen has 1 proton, so its atomic number is 1. Carbon has 6 protons, so its atomic number is 6. So it basically defines an element. If I say there's an element that is having 6 protons, that means that it is the 6th element of the periodic table. Like if I say neon is the 10th element, so that means neon is going to be having 10 protons and 10 electrons present inside it. Okay, now key point, every atom of the same element has the same atomic number. Now same elements, the atom of the same element have the same atomic number. Got it? Like the thing I said right now, that if I say let's suppose fluorine is the 9th element, so its atomic number is also going to be 9. Okay, so it tells the number of electrons in a neutral atom. Okay, that means proton number and electron number is always same. That's why they cancel out each other's effect, and as proton number and electron number is same, so they cancel out each other's effect, and as a whole electron becomes neutral. Okay, in short, the atomic number tells us which element an atom is and how many protons and electrons it has. This is the main function of atomic number. Okay, now what is an element? We studied about what is an atom, but now what is an element? So an element is a pure substance. First of all, you need to know about this. There are pure substance as well as impure substance. We are not going to go in the depth of them, but still you need to know that any element is a pure substance that is made up of only one type of atom. Impure substance, they mix up different atoms, but this one is only made up of one type of atom. It cannot be broken down into simpler substances by chemical methods. We cannot break it down. Each element has a unique atomic number, which is the number of protons in its atoms. Elements are the building blocks of matter and combine in different ways to form compounds. Okay, now elements, they basically they combine in different ways to form compound. We're not going to be going in a depth of compound or mixture or anything like that. Okay. For example, oxygen is an element made up of oxygen atoms, and hydrogen H is an element of hydrogen atoms. Okay, like this. What is the identity of an atom? The identity of an atom is determined by the number of protons present in its nucleus. The number of protons is also called atomic number. Each element has a unique number of protons, so the atomic number tells us which element the atom belongs to. I've already explained you this. For example, an atom with 1 proton is always hydrogen. An atom with 6 protons is always carbon. In short, the identity of an atom depends on its protons. We define the element. Now if I say hydrogen is the first element, that means hydrogen's proton number is 1. If I say carbon is the 6th element, its proton number is going to be 6. Structure of an atom. An atom is the smallest unit of matter that retains the properties of an element. It consists of certain nucleus and moving out it. The nucleus located at the center continues protons, which are positively charged, and neutrons, which have no charge. Electrons, which are negatively charged, revolve around the nucleus in shells or energy levels. The number of protons in the nucleus is called atomic number and determines the identity of an atom. With the total number of protons and neutrons called the atomic mass number determines its mass. Even though atoms are extremely tiny, they are building blocks of everything in the universe. I've explained you everything. Now, first 10 elements. You need to know about first elements. So, first 10 elements are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. You can learn it like, hi, hello, listen, BBC News on Friday night. Okay, it's a trick to revise this. Okay, now. Proton. Now hydrogen has one proton, it's the first element. Helium has two protons, the second element. Lithium has three protons, it's the third element. Beryllium has four protons, it's the fourth element. Boron has five protons, it's the fifth element. Carbon has 6 protons, it's the sixth element. Nitrogen has 7 protons, the seventh element. Oxygen has 8 protons, so it's the eighth element. Fluorine has 9 protons, so it's the ninth element. And neon has 10 protons, so it's the 10th element. Now abbreviations. Now hydrogen is represented by capital H, helium by capital H and E, because we cannot do it helium, it's starting with that, so we're not going to do H because it's going to be similar as hydrogen, so we have to make it different. Lithium by Li, beryllium by Be, boron by B, carbon by C, nitrogen by N, oxygen by O, fluorine by F, neon by Ne. So you have noticed this, the abbreviations are in capital letters. So this is the thing that we need to remember. Okay, abbreviations are always in the capital letters. Next 10. So sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Now they also have different signs, like sodium as Na, magnesium as Mg, aluminium as Al, silicon as Si, phosphorus as P, sulfur as S, chlorine as Cl, argon as Ar, potassium as K, calcium as Ca. Okay. So yeah. Now, how to find number of protons? So the atomic number Z is of an element is always equal to number of protons of an element. So you can find atomic number from the periodic table. Now use the formula. Number of protons is equals to atomic number. If atomic number is given to you, that means this is the same as proton number. Okay. For example, element oxygen. So atomic number is 8. So what's going to be the number of protons? 8. Okay. Then how to find number of electrons? So in a neutral atom, the number of electrons is equals to number of protons. So if once you have the number of protons present with you, that means that you have already defined the number of electrons. So the atomic number gives the number of protons, so it also gives the number of electrons. Like K9 positive ion, that electrons is equals to protons minus charge, and A9 negative ion, electrons equals to protons plus charge. Okay, in this case you can do this. Okay, now neutral atom, that for example oxygen, now its atomic number is equals to 8, so proton is equals to 8, so electron is also going to be 8. And in ion, for example Na plus, that means sodium ion, proton is equals to 11, so charge is going to be, now you can do the charge calculation. After that we're going to get plus 1, that means electron is equals to 11 minus 1. Okay, you're going to minus it, that's equals to 10. And in ion, like Cl minus, that means chloride ion, proton is equals to 17, so charge the charge that we get after calculation is minus 1. So how you can find electrons? That is equals to 17 plus 1, that's equals to 18. So once you get plus in the charge calculation, you are going to minus it for finding electrons. When you get minus in the charge calculation, you have to add it in the for finding the electrons. Now how to find number of neutrons? So use the formula to find the number of neutrons, which is number of neutrons equals to mass number minus atomic number. You can simply minus mass number atomic number. If atomic number is not given to you, that means that that's definitely the number of protons or number of electrons. Okay, but mainly it's number of protons. Okay, mass number, that means that's represented by capital A, total number of protons plus neutrons. Atomic number capital Z, that is equals to number of protons. Okay, now step 2, you can like that subtract, like neutrons is equals to A minus Z, that means number of protons you can say simply that atomic mass minus atomic number. For example, oxygen, its mass number is 16, so atomic number is going to be 8, so neutron is equals to 16 minus 8, that's going to give you 8. Carbon, like mass number is 12, so atomic number is 6, so neutron is equals to 12 minus 6, that equals to 6. How to find mass number? So step 1 is know the formula, like mass number, that's capital A is equals to number of protons plus number of neutrons. Protons atomic number, and neutrons can be given or calculated. Okay, you can also calculate it or it can be given in the question itself. Add protons and neutrons. Okay, mass number is equals to protons plus neutrons. Simple, you can add this. Protons and neutrons, you can just add them to get the mass number. For example, oxygen, so protons are 8, neutrons are 8, so mass number is going to be 16, sorry. Carbon, in carbon it's protons 6, neutrons 6, so mass number is going to be 12. Now, this is basically an figure that shows the nucleus of an atom, including the shells and orbits. So in the nucleus, you can see you're having neutrons, which are having no charge, protons, which are carrying positively charged, which are alongside the neutrons, and in the shells or orbits, you can see, or in the energy levels, you can see that these electrons carrying the negative charges. Atomic number of protons, like here we're having lithium ion, Li lithium, so in the upper value they are given you the number of protons, which is 3. Its atomic number. In the lower value they have given you 7, which is atomic mass, which is number of protons plus neutrons. You can write the atomic mass first and atomic number downwards, like that's also fine. Okay, different styles of atomic structure and diagram notation, like lithium, atomic number is equals to 3 protons in the nucleus, mass number is equals to 7, that is equals to 3 protons per 4 neutrons in the nucleus. Li, like lithium, element symbols, no subatomic particles information. Li, now it has 3 symbol with atomic number, often seen in periodic table, and Li 7 symbol with mass number, often used to indicate particular isotope, and Li, that means lithium, with 7 and 3, that means full subatomic particle composition, often seen in periodic table. That means it is containing atomic number, atomic mass both. Two representations of lithium atom. Now here you can see 3 protons and 4 neutrons are present in the nucleus, and in the shell or orbit we're having 3 electrons present. Okay, and the other version is this, that here you can see that here how they have given you that they have just made 3 plus signs in the nucleus, balls and 4 balls containing no signs. That means neutrons and protons are present in the nucleus and atom, and the orbit you can see 3 balls containing 3 signs. And yeah, a more detailed version, but a little cumbersome for bigger atoms. Okay, atomic structure, you can see this atomic structure: protons and neutrons. So as a whole, protons and neutrons are called nucleons, are located in the nucleus of an atom. Electrons are located in energy levels surrounding the nucleus. Okay. So subatomic particles, relative charge, relative mass. Okay, so subatomic particles, protons, relative charge is +1 and relative mass is 1. Neutrons, relative charge no charge and relative mass 1. Electron, relative charge is -1 and relative mass is 1/2000. Okay, now the first, here you can see in this picture the first shell. Now this is very important. So this is only for the shell or the orbit of the energy levels of an atom. So the first shell has been filled with 2 electrons. Satisfy rule 1 and 2. You need to know this. The first shell, or the K shell, okay, first shell is called the K shell. So it always contains 2 electrons. Not more than 2 electrons can fit inside it. 1 or 2 electrons can only come in the first shell, which is a K shell. Second shell, the second shell, electron shell, has been filled with 8. Satisfy rule 1 and 3. So 8, if it satisfies 8, that means it is obeying the first one. For 2 1, it's obeying the duplet rule, and for the 8th one it's obeying the octet rule. Okay, from oct you can do this, that it's 8. Okay, so the second shell, that is L shell, the second shell is L shell, that has 8 electrons present, not more than 8. It can be less than 8 but not more. And the third shell is incomplete. It contains the outer valence electrons. Okay, but it can also contain 8 electrons. Okay, here in this example it is incomplete, but it can contain 8 electron as well to obey the like to be stable like argon. Okay, octet and duplet rule. So octet rule, the octet rule states that atoms tend to gain, lose or share electrons to have 8 electrons in their outermost shell, valence shell, like the electronic configuration of a noble gas. This gives the atom stability. Now for example, sodium Na, that is equals to 1 electron in outer shell, it loses 1 electron, so Na plus outer shell now has 8 electrons. Chlorine, like Cl, 7 electrons in outer shell, so it's gained 1 electron, so Cl minus outer shell now has 8 electrons. Water, like H2O, oxygen, shares 2 electrons with 2 hydrogen atoms. Now what happens then? Oxygen achieves 8 electrons in the valence shell. Key points: most atoms follow octet rule except hydrogen, helium, lithium, and beryllium. They are exceptions. Okay, they're exceptions. Duplet rule. So the duplet rule applies mainly to hydrogen and helium, which are stable with 2 electrons in their outermost shell. Like the first shell, these elements do not need 8 electrons. Like 2 electrons are enough for stability. Now examples are hydrogen H. It needs one more electron to complete 2 electrons. Like it forms H2 molecule by sharing electrons. Okay, so H2 molecules becomes by sharing the electrons. Okay. Helium He already has 2 electrons, so it's naturally stable. So it is also a noble gas. Okay, it's naturally stable. Like if I talk about neon, it is also a noble gas. Okay, it's also stable. It's naturally stable. Argon is also naturally stable. Key points: only applies to the first period elements, that are hydrogen and helium. Duplet rule. Okay, it's called a duplet rule because they aim for 2 electrons instead of 8. Dup, like double, that means to add. Okay. Okay, now here we are having a carbon atom with thus. So here in the carbon atom you can see that 6 plus signs in the nucleus, that means 6 protons, and 6 without any sign, that means 6 neutrons are present in the nucleus of an atom. In the orbit, in the first shell, you can see there are 2 atoms, that 2 electrons present, that means it's obeying the rule. Okay, it's obeying the duplet rule. Okay, and in the second shell you can see there are 4 elements. Okay, 4 electrons present. Okay, so 6 electrons in total, 2 in the first shell. In the second shell we're having 4. As a whole we're having 6 electrons. Okay, 6 protons, 6 electrons, 6 neutrons. So electronic configuration, so K shell is having 2 and L shell is having 4. So 2 and 4. Okay, and drawing atomic diagrams. Atoms are made up of 2 major parts: the nucleus and electron cloud. Electron cloud contains multiple energy levels which are drawn as rings. Each energy level can hold a certain number of electrons. Lithium ion, here we're having 3. So 3 is the number of protons. 6.94 is the mass number of lithium, and Li is basically its abbreviation. Now based on the atomic number provided, an atom of lithium will have 3 protons and 3 neutrons. The number of neutrons can be found by subtracting this atomic number from the atomic mass. Now 7 minus 3 is equals to 4 neutrons. In the nucleus of an atom, draw 3 protons and 4 neutrons. The 3 electrons will be drawn in the energy levels like rings outside the atom. In each atom, the first energy level can hold 2 electrons. The second energy level can hold maximum 8 electrons. Okay, so bye for now. Wait for the next video for studying more about an atom. In the next video I will come about more detail of an atom. We're going to be talking about the scientists who gave their thoughts about different types of atoms, and at the end how we came across that. Thank you so much for listening to me. Bye bye, take care, Allah Hafiz everyone.